Ladies and gentlemen, good morning and welcome back to the Day 2 Asia Pacific Dominant System Forum hosted by Miney and ICANN. Before we begin, I would like to take this opportunity to thank you for joining us today and also to express our deepest gratitude to our sponsor for their support to this forum. I'm Ame, your MC for today. As for your information, this is the first Asia Pacific DNS Forum for 2022 and our theme is Beyond Technology, the Revolution of DNS, which will feature a multitude of topics discussing the role of the DNS from multiple perspectives. Once again, I would like to highlight that you can win prizes by attending the forum session. Here is how it goes. We need you to attend all the forum sessions, engage with the speakers throughout the Q&A and visit the virtual booth to collect the points. The top 10 participants who collect the most points will receive an Amazon gift card worth USD 50 each. Ladies and gentlemen, this session is entitled DNS Direction and Network Operators DNS. In this session, we will be discussing how DNS encryption will alter the way subscribers interact with the internet access services and how the new network architecture focused on the edge may change the resolver deployment and also the management models. Our moderator for this session will be David Chiu from Miney. Ladies and gentlemen, let us welcome him. David, the floor is yours. Thank you.
Thank you, Ame. Thank you for the morning and welcome to everybody. And I believe they'll be coming from different parts of the world. So good morning, good afternoon, good evening to all of you. So today we have an interesting speaker. His name is Bruce Van Nuys. Bruce, hello, welcome.
Hello, David. How are you?
Great. And I believe your side is nighttime, I'm sure.
It's evening. It's 6 p.m. I'm on the west coast of the United States.
Right, great. So for the general audience, let me introduce Bruce a bit. He's the senior manager for product marketing from Akamai. Now, Bruce actually has about 25 years in experience in networking and security industry, focused on service provider. So Bruce is an active contributor at the industry events and forums, and he speaks a lot about DNS security, privacy, and data analytics. Now, today's topic for Bruce is interesting. So we're talking about the DNS directions and network operation topic. Now, I believe this topic itself could concern some of you operator out there, or even some of the DNS management or even registrar out there. Now, Bruce, would you able to give a bit of insight about this particular topic and give us a presentation on this? Over to you.
Yeah, absolutely. I put some slides together and let's get those displayed. I take it people can see the title slide now?
Yes, I can see that. Okay, great.
Yeah, I'll just start right in. David and I did a review of this last week, and I think you'll find it informative. Just quick background, it's great to have the opportunity to talk at this venue. I've traveled, there was a time when I traveled around the world and spoke at venues like this, and it was really enjoyable, and I'm sure everyone in attendance is looking forward to the opportunity to go meet in person and have all of the important discussions outside of the presentations. So as David indicated, I've talked about DNS a lot. I've worked in that area for more than 10 years at this point. I actually was at a company called Nominum before, and they were kind of known in the industry for DNS, and they became known for research work they were doing using DNS data, and it happened that there were certain events in the industry that aligned with that really nicely, and so I spent a lot of time in Asia in particular talking about that, and I'll cover a bit of that today. But my presentation focuses on three different areas. Basically, DNS encryption, that's something that came on the scene. We're coming up on about 4 years. Work started in the IETF about 5-6 years ago. It was really a result of concerns about privacy, and I'll talk about that. It's become a pretty visible topic, and I think it's important to network operators. So I'll talk about what that means and why network operators should be aware and potentially take some actions. Talk about DNS attacks and security. We all know DNS is a great target, and there are various reasons for that. And so I'll give some perspective there. It's an area that we've been very, very, very heavily involved with for many years, and it's central to the successful operation of the internet and in any network that exists on the internet. DNS is pivotal. Everyone, I think, in the room appreciates that. And then I'll talk a bit about subscriber experience for network operators. We know that's a really important consideration. A good subscriber experience enhances subscriber satisfaction, and happy customers are customers that are retained and potentially will buy other services. So there's strong incentives to focus on subscriber experience as well. And I'll talk about what that means, especially with respect to DNS. So if I can get I'm only going to take a minute here. DNS touches everything. I think there's a lot of familiarity in the room. Resolvers connect subscribers to devices and their devices to web resources. To do anything, you need to use the DNS. Network operators deploy resolvers. In most cases, we know in some instances, there are places where network operators choose to point their subscribers or users at some of the open DNS solutions that exist out on the internet. I'll talk a bit about that. Authorities are where all the information in the DNS is published. So anyone who wants to have any kind of presence on the internet needs to publish domain names in the DNS. And I think it's fair to say that the DNS itself really defines the subscriber experience. It impacts responsiveness, availability, security, and location awareness. So if there's any issues with any of those things with regard to the DNS, it has a direct impact on what the subscriber experiences when they're trying to do, at this point, virtually anything on the internet. There's almost nothing that doesn't use DNS. So it's just to set the stage, and for some of the things I'll talk about next. Let me talk about DNS encryption. Like I said, the IETF really began to focus on privacy after some of the revelations from Edward Snowden. We're going on, I think, more than 10 years since that happened. And when that happened, it really raised concerns of the entire community, and they felt as though it was important to pay a lot more attention to privacy. In the old days, the good old days of the internet, privacy was always a consideration, but the protocols hadn't necessarily been designed for privacy. There was really more trust in the network itself and the people who operated the network. And there were fewer concerns about the presence of people who might use data inappropriately or gather data inappropriately. And of course, that's changed radically. We all know that data is the fuel for everything surrounding the internet, and there are people who use it appropriately, and there are people who don't, or organizations who use it appropriately and who don't. And so basically the IETF really set out to make the internet more private. And of course, in most cases, this means some form of encryption so that a third party can observe communications between someone sitting in their home trying to browse the internet and whoever provides content that they're trying to access. They wanted to minimize any unwanted intervention in that. And over time, they've progressively added privacy capabilities to more and more protocols. And so, as I mentioned a couple of minutes ago, starting about 6 years ago, they began working on defining how DNS traffic could be encrypted. And specifically for now, the focus is on traffic between a stub resolver, something that is implemented on most host systems or actually in applications, and the resolvers that are deployed by the network operator where someone connects to the internet. So this became a really visible issue, like I said, starting about 4 years ago, and pretty much all the leading sort of vendors and many other vendors who participate in the internet, was everyone today, have been a part of this, and many have announced implementations of the protocols. So what you see on the screen, this is just a sample of some of the vendors. There are actually others who are building implementations. Apple actually announced some security capabilities called Apple Private Relay. I'll talk about those in a little bit. Microsoft has participated, so they're providing facilities so those who want to take advantage of DNS encryption can, and they can talk to resolvers that support the capabilities. Quad9 is an example of what I would call an over-the-top or open DNS service that has the ability to support DNS encryption. Google supports it with Android. Mozilla supports it in the Firefox browser, and there, as I said, there are a few others. So some of the key players in the internet have, sort of bought into this proposition that internet privacy is important. And the protocols that were defined, there are currently 3 protocols that are defined, and as I said, these specify how communications between a client application or operating system with a stub resolver communicates with a resolver hosted in a network somewhere. So there's a protocol called DNS over HTTPS that operates by design over port 443. There's a protocol called DNS over TLS that operates over port 853. And then, of course, there's legacy DNS protocol, which operates over port 53 or for UDP or TCP and is unencrypted. But this diagram just gives you a sense of how those protocols operate. So the communication, if the client or stub uses DNS encryption, is encrypted from that device or application to some resolver that is encryption aware that correspondingly supports the protocols. So today, these are primarily, in fact, almost exclusively, we're really only aware of a few network operators like ISPs that take advantage of these protocols or that have deployed them in resolvers that are available in their network. So it's primarily what I call public or over-the-top or open DNS services that support these protocols. And so, for example, if you use the Firefox browser, there's a set of trusted resolvers that are supported by that browser, and you can either configure another one if it's compatible, or you'll choose the one that you want to communicate with. So anyway, the reason that this is important for, I'm sorry, this provides just a little more detail on some of the client implementations, just some specifics. And I think this is a fairly complete list. I know there are a bunch of Linux implementations too, and I didn't include those just really for brevity. The list gets really long, but this just gives a sense of the support in the operating systems. You can see Android and iOS 14 plus or Mac OS 11 plus support DOT and DOH. Windows 10 has support for DOH. The Firefox browser, Chrome, and all the Chromium variants support DOH. There are various apps that support these protocols. So for a user who is concerned about privacy, they can load these apps and use these resolvers, which are hosted on the internet. So 1111 is a resolver, or actually a whole set of resolvers that are Anycast, hosted by Cloudflare. There's an app called Intra. It was produced by Alphabet, some organization within Alphabet. And then there's another app called Quad9 Connect. Same deal, you can load it and talk to the Quad9 resolvers. There's also CPE that supports these. In the diagram before, I didn't really talk about it, but CPE can proxy DNS requests that they see in the clear and proxy securely to a resolver that supports the protocols as well. So the point here is that things are just sort of lining up where these protocols are going to become really important. I wouldn't suggest today that they're mainstream, but I think over time the objective is for them to become mainstream. That in some form of encryption is the default in the internet. Let me talk a bit about Apple Private Relay. It's a privacy feature that was built into iOS 15 and Mac OS. It's designed to protect web browsing in Safari, and as part of that, it encrypts all DNS name resolution queries. And so if someone takes advantage of this feature, what it means is they use DNS resolution infrastructure that's sort of guided by Apple. And they have very strict, very rigid requirements for the vendors that they work with that supply the DNS resolution services. Private Relay is in beta. It's actually been out for a long time. It was like June of last year that they announced it, and it went live, I believe, in like September. And so they've been getting experience deploying the protocol at scale since that time. They have, I think, fair to say, a lot of airtime, and they're being really smart in terms of what I talked about earlier, user experience in particular, working through, how these protocols really behave in the wild, because it's obviously radically different than how they behave in any sort of controlled setting like a lab or proof of concept. So users can turn these protocols on today if they choose to. And again, what that means is if yesterday they were connected to a resolver in an ISP's network, when they turn these protocols on, they no longer use that resolver, they use another resolver, and the traffic is encrypted, and it uses DNS over HTTPS, so it's impossible to see the DNS traffic in any way. You can't tell it apart from regular HTTPS traffic. They look exactly the same. So there's no way to really see the DNS traffic anymore as a network operator. The other trick with Apple Private Relay, they did something else. They wanted to sort of take privacy to the ultimate extent. And so the way that it works for DNS and actually for Safari is there are, there's a slight difference in the protocol. They use what's called the oblivious DNS over HTTPS, and it introduces another middle box into the network. These are ODO, oblivious DNS over HTTPS proxies that are controlled by Apple. These proxies see queries sourced from clients, and so these proxies, of course, can see that client's IP, but they then they essentially translate that IP address to another IP address, and then they send the query itself to what's called an ODO target, which is a resolver that's controlled by a third party. It happens that Akamai is one of the companies that supplies those services as part of an arrangement they have with Apple. But the point of this is no entity in the network can see both who the user is and where that user, or what that user is querying for. So they have absolutely no way to understand, a particular IP address somewhere on the internet is trying to reach Facebook or whatever it might be. The ODO proxy only sees the client IP, and the ODO target only sees the query. It doesn't see the original client IP. So everything's obscured in the network. So this is sort of the ultimate way to ensure that nothing that isn't supposed to see the traffic can see anything that's useful to them. There's really no way to gather all the information that would be needed to collect data that would be useful for anything. This is sort of the latest innovation with regard to DNS privacy or DNS encryption. And I went through that long discussion, and obvious question is, well, I'm a service provider. Why should I care about DNS encryption? I'm a network operator. If you just sort of look, or if you've been kind of watching the evolution here, I think one of the things you'll see is that public DNS resolution services, especially like Google or the 1111 service, are visible and credible. So if you read the media articles, they generally get very positive reviews. I think the media certainly is on board with the notion that privacy is important, and I think we all are. We all recognize that privacy needs to be respected. But the point is that either users or client implementations may make it easier for to bypass network operator or ISP's DNS. And if, as a network operator, you're comfortable with that, this may all be fine. But if, as a network operator, you're either you want to see that traffic because operationally you think it's important to have that visibility in terms of, in order to properly manage your network and again, ensure that right subscriber experience. Or if you're using DNS for other things besides resolution, for example, for security, which is something we'll talk about next, when subscribers or users migrate away from your DNS, it changes that picture. And there's a whole other issue here, which is in a lot of different countries, there are regulations that mandate that network operators, ISPs, need to implement filtering mechanisms to meet regulatory requirements. So for example, there are many parts of the world where certain kinds of content is considered inappropriate and needs to be filtered. And there's sort of universal norms for what that content is. There's, I'm never really comfortable talking about it, but there's kind of universal agreement that certain kinds of things that are available on the internet are inappropriate and shouldn't exist on the internet. For example, like child exploitation content, which is just really horrific. And so governments mandate that providers block any kind of access to those sites, and there's various ways that information is obtained. And if subscribers migrate away from a provider's DNS, then that sort of compliance is no longer possible. So there's lots of reasons why providers should care. And the reality is that depending on the implementation, either intermediaries gain visibility and control over the subscriber experience. So if a user says, gee, I want to use this public DNS, then whoever hosts that resolution service ultimately gets to see those queries, and they get to exert control. And in fact, they're central to the subscriber experience because they're resolving queries that allow people to navigate the internet in the way that they want. So this is kind of the motivation why providers should care. And I know, as I mentioned at the beginning, there are providers in certain parts of the world that have decided, you know, DNS is important, but I think I'm comfortable sort of outsourcing that. And so by design, they point their subscribers to services like this. But there are many others who feel quite the opposite, that DNS is central to the proper functioning of their network, and they need to pay attention to it. And so if they still have that belief, then they need to pay attention to these protocols, because there will come a day when it'll be very easy for users to take advantage of them, or they'll be configured as defaults for applications and operating systems, and you know, they won't have a choice. So the traffic will migrate away. So what can operators do? There's a great organization called the Encrypted DNS Deployment Initiative. They're actually, it's an operator-driven initiative, and their goal is to drive relevant standards for network operators. And the goal is specifically to create the same sort of JustWorks experience that users have today. So in other words, define the protocols that are used today to point subscribers to DNS like DHCP, for example, but update them so that they can take advantage of resolvers that support DNS encryption. And when someone goes on the network, they can just get pointed to a resolver that uses encryption automatically, just as they're pointed to a resolver that doesn't encrypt today. So we sort of urge that network operators, at minimum, take a look and are aware of this organization, and more importantly, participate. It's a chance to, you know, help shape these protocols. These are some of the standards. There's actually a lot of progress that's being made to make it easy for network operators, ISPs, to use these protocols, and the client vendors are on board supporting these mechanisms. And again, the objective is basically make it work the way it works today for encrypted resolvers. And so make it really easy and seamless operationally, and make it scale in the way that today's protocols scale for unencrypted resolvers. So there's some of the current standards that are being defined in a working group called Adaptive DNS Discovery, and there's some details that you can read about what these standards do. We're very active here. We have multiple people that attend, and we're very committed to driving these standards in a way that benefits the network operators that we work with around the world. So guidance on this is gain deployment experience with encrypted DNS or implementations that are out there. We think it's really important for providers to be aware. There will come a day when we think this will be sort of mandatory. Just like everything else that's happening in the internet, you're just going to have to accept that this is something else that's going to be encrypted, and certainly operationally it adds some complications, but it's something that it's probably time to gain some experience and really understand, track the standards and contribute to the standards. And most importantly, make sure that your subscribers or users are aware of your privacy and security practices. One of the advantages some of the the over-the-top services has is they get all this media coverage when they announce a service, and everyone thinks, oh, gee, this is private, and so it's better, and they connect to it. It may not be better at all. And the reality is that whoever hosts that service actually gets to see their data. So it may not be as private as they think either. And I'm not trying to undermine those services at all, but it's that classic case. It may not be as good as it looks, but a lot of users don't really know that. And so providers have a trusted relationship with their subscribers, and they should let them know, well, we have privacy practices too, and we have security practices too. And, ultimately we'll support these protocols. So we're going to do the same thing. So, we think it's better if we keep the traffic and give you the better experience. There's a great paper that sort of covers everything I covered. It was written by a group called ENISA. That's a European Union agency for cybersecurity. It's funded by the EU, so it has absolutely no commercial emphasis of any kind. Vendors do not have any influence over anything they do. And this is a pretty good publication. They put out like 2 months ago. So if you want to hear or learn a bit more than what I just said and kind of understand all these issues, I thought this document was quite informative. So let me talk about the DNS and security. I talked a lot about privacy, and the reality is that privacy and security intersect. So networks that aren't secure open users to interception of their data. And if someone can, compromise a machine of a user, there's obviously a lot of things they can do and lots of ways that they can get the data. So the fact is that privacy and security really intersect. An insecure network is likely a network that's also not particularly private, because if there's, if you open it up to that sort of activity, it opens up the whole privacy issue quite widely. And compromise of privacy it can have a lot of different implications, both in terms of just personal information or valuable information that's stolen or otherwise compromised. So they're really highly interrelated. And when you think about DNS, there's really sort of two sides of the same coin. There's the idea of securing the DNS itself, and securing the DNS itself has noticeable implications for internet security, because there are ways that you can compromise the DNS that very directly compromise security. And then there's using the DNS to improve security. So they're interrelated things, but they're both sort of centrally focused on the DNS. And in this case, I'm actually talking about, I should be specific, it's DNS resolution. So the resolvers that are deployed by network operators. There's also implications for the authoritative side, and I'm really going to focus more on the resolution side. So everything you'll hear in the next few slides is related to that. At the beginning of the presentation, I mentioned I made the rounds of a lot of conferences like this in the past. The DNS has always been a target. So there's lots of ways the DNS is exposed. Cache poisoning has been a problem from the very beginning. So basically, tricking a resolver into caching a result that's not a legitimate result. So there's ways that hackers can trick a resolver into thinking, oh, that recursive query that you sent, here's the answer for it, and it's really not the correct answer. So cache poisoning has been around a long, long time. This is really visible in 2008. Everyone remembers that, the infamous Kaminsky cache poisoning attack, which literally was like a big worldwide issue. We were right in the middle of that at Nominum. Our guys worked really hard. We already had actually great protections in our resolver. Kaminsky himself, when he gave his presentation at Black Hat, talked about the fact that it took a long time to compromise our resolver because we had a bunch of protections that were built in. We added even more. So we were way ahead of the game to begin with. We went out and sort of talked about other ways to protect the DNS. One of the other things that can happen is domain hijacking. So this is really more of an operational thing. There are different ways that you can hijack domains. And actually, I should be clear, that's really more of a resolution thing. There's DNS tunneling. So it's a way to use the DNS to transmit information. And then there's DNS DDoS. And this was also a huge issue. Starting in about 2013, there were clever ways to fire queries at DNS resolvers and either get them to give back like huge answers, so it was a way to amplify, or there are ways to just fire queries at the resolver that had no answer and essentially tax both the resolver itself and the authorities, because the resolver had to recurse. It was a query that wouldn't resolve. It was non-existent domain. So this was a big issue, because if you ran a resolver and you were getting these queries, oftentimes it severely stressed or caused the resolvers to fail altogether, since they couldn't handle the load. So from that list, some of the things are protocol issues, some are not. Like I said, some things are more operational, just making sure that the resolver and access to the resolver is properly secured and patched and all that sort of stuff. Some, like cache poisoning, required some changes to the protocol. So for example, DNSSEC, which had been specified actually for some time when the Kaminsky thing came out in 2008, but hadn't been widely implemented, suddenly became really important. On the DNS side, there really weren't any changes to the protocol, but what it meant was thinking about operationally, how you could tune your resolver to potentially filter the DDoS traffic and minimize the impact of an attack. So there's a bunch of different things that happen throughout all of this. There's a great presentation my colleague gave at an organization called DNS OARC in Bangkok. This was about 3 years ago. And he covered this whole history of all these attacks. It's really informative. I put the link. So if you're interested, you can go take a look at that. And OARC is also totally non-commercial. There's no selling going on there. It's a great venue if you want to be aware of what's going on in DNS. So the industry's been responding to this just continuous exposure of the DNS. And it's really no different than many, many other protocols. DNS by no means is sort of been singled out as the sole target. All the protocols have issues. It's just DNS is really attractive. And when it fails, it tends to fail quite visibly. So on the flip side, if you take the actions to ensure your resolver is secured and patched, and you get an implementation that says impervious to cache poisoning, you support DNSSEC and all those kind of things. The flip side of the coin is thinking about DNS as a security solution. So the DNS can also be used to help secure your network or secure your users. And part of the reason it's important to think about the DNS as part of the solution is DNS is very widely used by malware developers. And there's a bunch of reasons why that's the case. I'm not going to go through all these, but because it's such an essential, critical protocol to make anything work in the internet, malware developers use it too. And so if you recognize that that's the case, and then you think, well, if we can just figure out the malicious ways in which malware developers use DNS, and there may be ways to block that activity. And so that's sort of the short story for why it makes sense to think about the DNS as part of the solution in securing a network. And like I said, this lists like all the reasons why malware developers use it. DNS is a great protocol. It's really lightweight. It's ubiquitous. So if you're an attacker, it's good. The downside is, everyone knows the DNS, and there's lots of ways to get information about, who you are, either directly or indirectly. So it makes it a little bit harder. But the reality is that the bias is still toward using the protocol. Anyone who tries to do some of the things that the DNS does on their own, or tries to statically deploy their exploits, discovers that has significant disadvantages. Related to that, given that this understanding that everything uses the DNS, including malware developers. So let's say I'm a researcher and I want to look at data to figure out what's malicious and what's not. DNS data actually has some really nice characteristics for security research. One of the nice characteristics is it's pretty straightforward to gather data from resolvers. Most resolvers are equipped to log the queries. It's also straightforward to anonymize that data. That's actually an absolutely critical consideration for any kind of security research. So there's pretty straightforward ways to both gather the data and to anonymize the data. And it does require some processing capability, and resolvers can source lots of data. So you need to be prepared for that as well. But again, those are solvable problems. You can get geographic diversity since resolvers are everywhere. And one of the other advantages is because of how DNS works. If you think about, you're using a browser, and the first thing a browser needs to do to get anywhere is make a query, a DNS query. So it's sort of early in the browsing activity. DNS is one of the very, very, very first things that happen. happens. And the same thing's true of malicious activity. In order for an exploit to activate or to perform some action, it needs to make a DNS query. And so the nice thing about that is, well, if you can block the DNS activity, you can block the malicious activity, and you can do so early in the life cycle. So there's another sort of advantage of why DNS can be part of the solution. Other is just more related to the research itself. It's relatively structured data, so it tends to be relatively easy to process because the format of a DNS query is very well known, and there's some variability in terms of what queries look like, but that's tractable relative to a lot of other data sources, which are much more diverse than DNS data. So I mentioned we did and do a lot of research on DNS data. It's something we've done for a long time and we got known for. And I just want to give you just a little sense of what that means, just to kind of fill out the picture here of why all this kind of makes sense. One of the things we have relationships with network operators around the world, and they send us their data. It literally is live streamed from their resolvers. So as I said, it's anonymized, but pretty much someone hits a key somewhere in Malaysia, and we can see that query a few seconds later in these systems that process the data looking for malicious activity. So the lag time is minimal. It's literally a few seconds from the time someone makes the query to the time it hits some infrastructure that's used for processing the data to determine whether something's malicious or not. So there's a whole set of steps that are used to process the data. There's some pre-processing to get at, well, there's a lot of things are legitimate, and I'll show you some examples of that in a minute. There's ways you can map the relationships among domain names, so you compare to publicly available, appropriately private information to determine whether queries are in some way related or related to things that are, in the next case, related to things that are known to be malicious. So you can look at a query and say, well, wait a minute, most of the queries from this TLD are malicious, so we need to pay more attention to this query because the probability that's malicious is higher. There's various machine learning techniques or AI techniques that can be used to, once you've established what a pattern is, to go and find other names that adhere to that pattern. There's ways to correlate relationships among names and then visualize the data to make it meaningful and get it on a block list somewhere. So this is sort of a high level view of what all that processing looks like. The beauty of it is that queries can come in and filter through this process, and what we get as a result is something's known to be malicious with a high degree of probability. In fact, we can scale that and provide different levels of probability that it's malicious or not, and make decisions about whether things should be blocked or handled in some other way. So let me just give you some kind of visual examples. One of the things that I think is pretty well known in the industry right now is new domain names tend to be more highly associated with malicious activity, and this relates directly back to something that I said earlier, which is malware developers use the DNS, and another thing that they do is they continually change the face of their exploits because they have to, because someone figures out this domain name is malicious and we're going to block it, and so they change the domain name. So what that means is, if you see a new domain name, it's a good flag that name should probably be evaluated a little more closely to see whether or not it's malicious. So we have a dashboard which shows, other organizations do this too, by the way, other security organizations, but you can see on the right-hand side, a bunch of different names, and it's literally sort of the pulse of the internet. When these come in, literally, it would have been the first time we had seen this query, and very likely, very, very, very close to the first time it had ever existed on the internet at all. So someone activates an exploit, they register a name, some device somewhere on the internet that it hosts that exploit, makes that query. We see it in our systems a few seconds later. We've never seen it before. We flag it, put it through a bunch more processing. Just again, trying to give you a sense of how all this works and why it kind of makes sense. One of the other things I talked about, how do you determine something's malicious? Well, it starts with, was it a domain name we hadn't seen before? And the second is, this is something that changes all the time, but some TLDs are more associated with abuse than others. And same deal, if you look at DNS data, you track it over time and you realize, well, some TLDs do a better job of policing for people who probably aren't doing the right thing with their domain names, and some do a better job. And I really want to emphasize, I'm not trying to call out any of the TLDs at all, but it's sort of a fact of life. We gave a presentation about this too, just about TLD abuse trends. I wish, excuse me, we want to do a repeat of this. This is something that changes all the time. But with the introduction of the generic TLDs, it became harder and harder to sort of police registrations because there's a lot of different commercial motivations and all that sort of stuff. And so it's really important to sort of track what's going on with the TLDs. And it's another kind of metric that you can use to categorize things as malicious or not. So what does this mean functionally as a network operator if you deploy a resolver? We talked about how the developers create an exploit. They need domain names in order to activate the exploit or to implement some function. They propagate that exploit. Devices make queries, and a resolver that's aware that a domain name is malicious can block that activity or not respond or something like that and prevent that exploit or feature in that exploit from being used. So pretty simple, pretty straightforward. On the resolution side, it doesn't really take any cycles to do that because you look in the same table that you'd look in to see if an entry is cached, and then there'd be a flag that says, oh, wait, that one's not good. So rather than just answer, you could block or do something else. You could take some other action. So from the standpoint of the sort of impact on the network, it's basically immeasurable. So just a little perspective here. We think it's important for network operators to maintain awareness of the threat landscape. DNS is central. Understand the impact of threats on the DNS networks and subscribers. Back to the sort of the privacy point or the DDoS point with network impact. Investigate technical and business implications of security solutions. Understand, well, what does it take to ensure that my DNS is secure? What does it take to ensure or to implement some sort of security mechanism with DNS, just sort of foundational security, just like all the other things you do to make your network work. Take some action to make your network more secure, and what are the costs of that, and what does it take operationally to do? And net, I think we've always sort of advocated, and we work with a lot of providers, make DNS a strategic network resource. It'll make a difference in your network. Talk about subscriber experience. I already talked at the beginning, how DNS is sort of central, and this is just a sense of how operational characteristics of the DNS can have an impact on subscriber experience. So on the resolution side, ensuring there's adequate capacity so queries can be answered quickly, ensuring there's adequate capacity for peak loads. So we all know there's amazing, funny things that happen on the internet, and there can be spikes of traffic. In some cases, the spikes are legitimate. In some cases, they're kind of semi-legitimate. People do really stupid things with the DNS. If you go to DNS OARC, you'll hear about those all the time. Everyone thinks the DNS is free, and so they think, we just, like their devices that'll make queries every second for some, and when those devices scale, it starts to have impact because they think, well, DNS is free, I'll just query it all the time. So you have to prepare for that. Availability is obviously critical, so build in redundancy. There's a lot of ways that can be done with Anycast or load balancing or whatever. Cache hit rate is also important, and so there's ways that can be managed to ensure that as much as possible answers are cached versus recursed, which takes time. Similar kinds of things on the authoritative side, but the relationship between the two is the hardest thing to control. If you run a resolver, you have no control whatever on the authorities, and so all you can do is ensure your resolver has as much capability as possible to cache answers, for example, very smartly, and minimize the impact that authorities can have on subscriber experience. So another kind of angle here in the market, there's all this talk about the edge, and in networks, there's the new notion of edge computing, and edge is distinctly different than cloud. Cloud is obviously massive today, but edge is slightly different. The whole idea is certain kinds of services are going to migrate closer to users. So for example, Akamai has a CDN, and the whole point of the CDN was get content as close to users as possible. And there's a belief that particularly with the emergence of the Internet of Things, that it's going to be important for all kinds of services to run closer to users in order to ensure that those services perform correctly. So it's sort of the whole next level of CDN for Internet of Things and even sophisticated applications running on devices like mobile phones. So the edge is going to become more important, and there's lots of different articles that talk about this. We have providers that we work with that are looking at moving DNS closer to their subscribers as well. And they want to do this so that, like everything else that they want to make highly available, the DNS is highly available and it has an optimal path, so that queries can be answered as quickly as possible. So, there's some obvious advantages to this, but the disadvantage is it scales differently, because typically when you put resolvers closer to subscribers, it means you need more of them. So you need to think about what that means. And usually what it means is new requirements for instrumentation and automation. So you have to think about the infrastructure and the capabilities that you need in the infrastructure. I've just generically outlined what some of those might be. Just doing plain resolution is probably not adequate today. It's useful to have some telemetry, so you have some data, so you can really figure out, well, is this thing doing what I want it to do, and what's the trend? So when do I need to prepare for more capacity? Policy is very useful for managing the way that queries are handled. Resolvers can source a lot of data. Data is a really good thing, but you need some sort of way to capture the data and stream it and send it to databases or storage for some sort of evaluation or reporting. Everything needs to be programmable with APIs. There's infrastructure that's needed to orchestrate all this, because you've got lots of resolvers. You're probably going to want some sort of automation. And so you need some kind of orchestration, and there's different capabilities that are needed for that are also illustrated on the slide. So guidance for this, monitoring the DNS experience. We're finding our customers, the providers we work with more and more are really interested in this. And, depending on their level of interest, they go deeper in terms of the kind of data that they gather. But they're just a lot more vigilant about capacity planning and understanding what the thresholds are. So basically defining, hey, when we hit a certain threshold, we need to add capacity. Underneath this is, what are the usage patterns? When something goes wrong, what does that tend to look like? So if you have a problem, there's a high probability that you've sort of characterized what that problem is. You know what the resolution is before it becomes critical, and you have systems that are down or overloaded and really not functioning properly. Goal is just enable some sort of rapid response to operational events. The whole edge thing, I have to be fair, has taken a while to emerge. I think it's one of those things that's been talked about for a long time, but I think when it happens, it's going to surprise everybody, and they're going to say, oh, wow, yeah, edge. Yeah, we've been hearing about that we're going on like probably 7-8 years, and now it's finally happening. So just kind of staying aware of what's happening with those services and anticipating subscriber needs is a useful thing. And then investigating automation for DNS infrastructure. So I guess I'll summarize. I talked about a lot of market trends throughout this presentation. It's something we pay attention to because it affects the people that we deal with. Our business, the business I'm in, is network operators exclusively, ISPs and mobile network operators. And these trends are all good because they drive interest and use in the internet, but change is really hard. We're aware network operators operate at scale, and operating at scale is really hard. And when things change at scale, it's even harder. And we know that, they're tough businesses. They don't have the same kind of margins that Google does. So you can't just throw money at every problem. You have to kind of think about it. So we know that all these great trends that users love are hard for our customer base. But what we think is, kind of changing the mindset and making DNS a strategic network asset is really part of it. Just making it kind of fundamental to the way that you think. And instead of like, yeah, DNS, we have that, we pay attention to it. Of course, we make sure it works properly, but think about it a bit differently in the sorts of tools that you have at your disposal. Make it a little more strategic versus just some other system in your network that just gets a little bit of care and feeding now and then.
Hey, Bruce, I think this is a very, very good information. In fact, you have a lot of things to share. Yeah.
Yeah, I hope, how would I do time-wise?
We'll run a little bit, but we do have an audience that her name is Susan Wolf. She has a couple of questions, and she'd like to know these two things. First one, maybe I'll read out to you and then see whether you can address it. So she said, IETF works on DNS related topics currently done in at means that the encrypted service discovery, D drive, especially on the privacy-driven work, such as the DOT, DOH, and DNS OP, everything else, which is the like the RR types of support this protocol and updates the best approach. So, what do you think about the DNS practice, DNSSEC practices in this area?
Yeah, I didn't cover those, and I have to be really honest. The presentation had the work that's being done around kind of operationalizing these protocols so they're most suitable for network operators. But yes, the other areas that she cites are equally important. So there's continued work on DNSSEC, and there's also some other work going on around the protocol. There's some interesting things going on to make some of the DNS error messages a little more visible, and there's some reasons why that it could actually be useful, even for the average person. So there is more work going on than I cited, and I think she gave some examples. I also noticed she put in a link to DNS OIRC. I can't emphasize, if you want to understand what's going on with DNS, that's the place to go as a network operator. I think it's fair to say that all the experts convene at that venue, and you hear the very latest, and that's a great resource to just stay on top of what's going on with DNS.
Right. And then she also wanted to know more about the DNSOrca.net, you know.
Yeah,
I think that one probably probably that one we might want to share some detail with Susan on this. Susan, thanks for your question. Okay. Now, Bruce, I think in the essence of time, we might want to end this. Okay, and thank you for the insightful. Definitely would like to call you back for some of the presentation that you did. Okay, I think that's give us some idea of how critical things can be in moving down the road. So with that, I'd like to end this session. Over to you, Amit.
Thank
you. I appreciate your time.
All right, thank you, David and Bruce, for the very insightful discussion. And before we go, kindly fill out the survey that will pop up in front of your screens. As for further feedback, kindly fill out the form that has been provided on the chat box, and don't forget about the Amazon gift card worth USD 50 each that could be yours. For more details, you may visit patentforum.my. The next session is on globalizing effort to mitigate DNS abuse. We start at 10 a.m. in UTC +8 in UTC. We'll see you there. Thank you.